Now see here solar cells. Solar cells are also here a PN junction diode, but they are made for the special purposes. It means these diode are actually works on the principle of the photovoltaic effect. So, the solar cells no biasing is done. Suppose if you have taken like this is the PN junction diode, this is your junction area, this is the P side, this is N side. Now, when the energy here or the photons, that means h nu greater than energy gap of the semiconductors fall on at this junction, electron and hole pairs are generated. You know, at the junction this is here the negative side and this is here positive side. So, all the electron and hole pair generated. So, the electrons are collected to the N side and holes are collected to the P side. When you connect this solar cell with a load with a resistance here R, then the current flows like this, because due to collection of the hole at this region, P become as a positive and here this one becomes as a negative. So, it supplies the current. So, in this case here it is a source of current, it is giving the current here and its graph IV characteristics can be drawn here in this manner, that means VI characteristics like this. It supplies the current. So, the VI characteristics is in the fourth quadrant. This is here the open circuit voltage here, this we call it open circuit voltage and this is called here the short circuit. So, this is about the solar cells. So, solar cells are here giving out the current, no biasing is done, take care, like in the LEDs and the photoelectric cell. In the photo cells, photodiodes and LEDs, here the biasing was done there, like one was the photodiode was in the reverse bias and LED was in forward bias, but here no biasing and it is supplying the current.